All right, last part of this, part 3. I've got two similar triangles, so remember I'm going to draw the small one separately. I might even want to draw the big one separately because there's a lot of adding and subtracting going on here. So it says given that these are parallel. So because these are parallel, that means I know that the triangles are similar. Okay, so, and we know they're similar because parallel lines have congruent corresponding angles. So that means that these angles are going to be the same as these angles, which means that these angles are going to be the same as these angles, since they're parallel, and we have this angle. So we have angle, angle, angle similarity. Anyway, this is going to be 16, right? 12 and 4. This is going to be 4. This is going to be 28. Whoops. So this is going to be 28. So what's this going to be? Well, we're trying to find what SO is. So that means I got to find out what this is. I'm going to call this X. So this one is the whole thing minus 28. So, or 28 minus, I'm sorry. We're going to call this X. If we find this out, then we can subtract that from 28. So, now a proportion. 16 over 4, small over big, is equal to small over big. Or excuse me, big over small. 28 over X. Cross multiply, you've got 16X equals 28 times 4, 112 divided by 16, X equals 7. So if X equals 7, then 28 minus 7 equals 21. That's what SO equals. Similar process here. What is the length of AD? So we're going to call this X. So we're going to say I've got two triangles. One of them is X. This is 45 and this is 9, so 45 minus 9 is 36. 36. And we've got another triangle that's bigger, that's 45, and X plus 6. So we're going to say X plus 6 over 45 equals X over 36. So now we cross multiply. We say 36X plus 216 equals 45X. So subtract 36 from both sides, and I have, right over here, 9X equals 216. So X equals 24. The exact length, so what I am looking for here is for you to work in radical form. If you see that this is 6 and this is 3, my hope is that you will be able to recognize this and go, oh, wait a minute, this must mean it's half of an equilateral triangle. That means this is a 60, 30, 90 triangle. You could use the Pythagorean theorem here to find out the length of the third side, but it sure would be difficult. Plus, you'd have to give it without a decimal approximation. Okay, if this is 6, this is 3, this is a 30, 60, 90 triangle, that means this one is 3 times the square root of 3. That's the rules for a 30, 60, 90 triangle. What is the measure of BCA? BCA, well, we already said that's 60 degrees. Triangle JKL is shown. Determine the measure of angle L to the nearest tenth of a degree. So here's angle L. I'm going to call that theta, so you're used to seeing this Greek letter as a measure for angle. So I'm saying this angle We need to know what that is. So from this angle, we have the opposite and we have the adjacent. So I'll say tan of theta equals opposite 4 over adjacent 15. So 4 divided by 15 is 0.266. So what we need to do is take the inverse tan of 4 over 15. Theta equals 14.9. Question number 43. Create 3 trigonometric equations for triangle ABC. So I'm just looking for sine of 20 equals opposite over adjacent. Cosine of 20 is equal to adjacent over hypotenuse. Did I just say sine of 20 is opposite over adjacent? That's tan of 20. Whew. Guess it's getting to the end of the year, huh? End of the day. This is opposite over adjacent. That's tan. So sine is going to be opposite over hypotenuse, x over z. All right, here we've got an isosceles right triangle, otherwise known as a 45, 45, 90 triangle, because we've got 90 degrees, and then the other two angles have to fill up the rest of the 90 degrees, so they all equal 180. So this is 45, and this is 45. So if xz is 12, what is yz in simplest radical form? So if we know something about the 45, 45, 90 triangles, we know that if this was A, this would be A times the square root of 2. So let's find what this is. A times the square root of 2 equals 12. So now we divide by the square root of 2. So now how do we express this? It's important you know how to express this rationally so you can expect to see that answer on a test. It would be like this. Let's multiply the top and bottom times the radicals, the square roots. And you've got square root of 2 and 12 times the square root of 3, or 6 times the square root of 3 when we simplify those. If instead xy is 5, what is xz? Okay, this is actually easier. It's 5 times the square root of 2. That's what we do with 45, 45, 90 times the square root of 2. All right, here we go. Solve for all missing sides and angles. We're going to round to the nearest tenth. So let's say from here, cosine n is equal to the opposite 4 over 13.6. So we take the inverse cosine of that, and I get angle n. The measure of angle n is 72.9. Okay, then 72.9, let's subtract 180 minus 90 minus 180 minus 90 minus, I'm not doing this right, 180 minus 90 minus 72.9 equals, wait, did I do that right? Sorry. Yeah, this is 72.9 plus 90. Let's try that again. 180 minus 90 minus 72.9 equals 17.1. Yeah. So measure of angle P equals 17.1.